This is Barry Hutt speaking from my sprawling studios in Cedar Park, Texas. So thank you very much for taking some time out of your day to join us for this presentation. Today, the show is featuring a discussion around ADAS and EV and how it's changing the game in safety today. I set a few objectives for us. I try to keep this simple, but I hopefully at the end of the day, I teach you something, whether it's a new word that you've learned, a new tool that you've seen that you didn't know about. We'll talk a little bit about AI and ML at the end and some of the interesting things that are going on in there. But at the end of the day, what I want to do is help engineers find more time and more time to do engineering work. So that's the idea behind here, and we'll keep it simple. And again, if you have questions, put it into the chat box. We'll come back at the end of the show here, and we'll do it. We'll try to cover as much as we possibly can. I've got a lot of material here. I'll try not to just talk at you. It's tough to do this in a one-way conversation, but we'll give it a shot. So just a little bit about Viviota. We've been around now since 2016. My co-founder and I rolled out of National Instruments. The vision really was to develop, to be a software focused on data that develops solutions for engineers. Now, a lot of the work we've done has been around automotive. You can see by the icons to the left, some of the world-class household names that we've worked on projects with. But what we'll show you today can be applied in many different ways to many different industries. NASA, we have two projects going with NASA, one in Johnson and one out on the West Coast. We've got Stryker Medical that does medical instrumentation, KLA-Tencor, which is semiconductor. So if you think about the R&D process, that is, if you're building a discrete thing, then this process will be relative to that. But today's focus will be on automotive and test safety. In the center, you see we've built an ecosystem of partners out there that we do business with on a daily basis. Either we could do selling, we do marketing, we do actually joint delivery of products and solutions to the marketplace. And we'll touch on some of these here as we move on through this presentation. But the focus today is about R&D and the transformation that's going on in the automotive industry. My goodness, when you think about, forget COVID-19, which is gonna hit us all in some very large ways. If you think about what's going on in automotive in terms of, I'm taking a gasoline engine out and I'm going to replace it with a big battery, and the implication to the supply chain, the implication to every part of this, of building a car all the way down to safety is changing. There's going to be new entrants in the marketplace. The world of transportation is changing so fast. This morning I was looking at, I'm a bicyclist, and I happened to look on a website, and I got an email from two new companies that are building e-bikes, with batteries on them, generate over 750 watts, and you can drive these bicycles up to 50 miles an hour. And if you think about in urban areas, what that's going to do to your local transportation and bike lanes, I think we're just at the very beginning of a new renaissance in a new area. The way people fundamentally transport people and goods is in for a dramatic change. Fundamental to that is the R&D process. Here at Viviota, we practice agile software development techniques. So it is really, if you're not familiar with agile, it is an iterative approach where you do short sprints, you demonstrate what you've done, you look at it, and you iterate on that. It works really well for software. It's now also being applied to the discrete world in broad ways. There's a lot of thought going on. This thing called Industry 4.0 in the center is important to that process, but there's also this thing called OT Edge. If you're not familiar with the term OT, it's operational technology, and this has to do with the R&D manufacturing operations within a company. And one of the things to be aware of that this is a trend we saw when we started the company. In 2012, there was about 4 billion sensors a year being shipped. This year, over 60 billion sensors will be shipped. Now, think about 60 billion sensors and the purpose of a sensor. It's to generate data. And that data is utilized not only in the end device, which let's say in this case is an automobile, there's over 250 sensors in your car. But in the process of building that, many more sensors are utilized. Every part in that car is high tech, from the TPMS systems, the air control systems, to your mirrors, to your infotainment system. Sensors are incorporated in the development of that as well as in the end product. So, you know, tools and techniques, and this is all creating a challenge for engineers. And engineers are some of my most favorite people in the world. And it's probably because my dad was an engineer at IBM. My two brothers were engineers. I'm a computer science guy. I was never smart enough to be an engineer, so I had to go to the software side of the house. I'll say that. But really, I've never met an engineer who gets up every morning and says, "Hey, I want to spend my time fighting fires today." The engineers I know really want to use the hard-fought education that they've received and engineering tools that they have in their brain and apply it to hard problems and finding creative solutions and driving innovation. The barrier to that is time, right? How do you do your day job, but also preserve some time to think and get some perspective? How do you find new insights from different sources? The amount of data is just expanding exponentially. And then I can't believe, as I traveled the world and worked with engineers, the old tools and techniques that are being utilized, especially in safety. I have one automotive company that I've worked with that is literally using software built in 1965 in Russia, believe it or not. And they've been using that for almost 40 years now. It still works, but talk about inefficiency and talk about trying to get to the new world of ADAS, and you go, you're just not going to get there from here with all of those complexity. So how do I take cost out of my development process? One of the biggest cost drivers is building test vehicles and vehicles that I destroy in a test. So it's a destructive test, and by nature, it costs a lot of money, and companies spend hundreds of millions of dollars a year building test vehicles that they destroy to see how well it's performing. So how do I reduce that cost? Well, the more I can do in simulation, the more I can do model-based design. Clearly, what you're trying to do is reduce the number of crash tests that you do and reduce your cost. To do that, I got to have a data backbone, and I have to be able to share data frontwards and forwards in that process. It is a very fundamental piece to that. And it's one thing to have the data, but then how do I process that? If you're all familiar with Gordon Moore from Intel, he came up with what's called Moore's Law, where his logic was that the number of transistors on a piece of silicon was doubling every 2 years, and the cost was cut in half. And that's been happening for 50 years. So the amount of processing power that is being developed, and also a unique way to package the processing with storage and feed those pieces, is really causing a huge evolution to move closer and closer to where the action is. So I can enable things like just-in-time analysis, real-time streaming, all of those things that will have to happen in a car someday in real time is going to be important. But it also, it doesn't remove the need to be able to describe the data that is being put to use. It needs to be able to be distributed across an enterprise. It needs to be disseminated in new ways and calibrated in new ways so that it supports not only the tools that they use today, but the tools that they're going to need tomorrow to do this. So a lot of work is going on this thing called edge computing. One of our partners is HPE. They have a slew of new devices that they're working on there, and there's clearly National Instruments and many others that are into this space. So I always say that you need to be able to do analysis right from the car all the way to the cloud. Different classes of engineers for different jobs. The fundamental piece to that is your data backbone, and for that to be easy to do, you need data that is qualified, that it is, it's good data, it's cleansed and augmented with metadata, so it describes what's actually in there. It's put into a file format that everybody can use, and it's organized and classified so that you can do discovery and you can find what you're looking for really fast And once you find that data, you need to do analysis and generate reports. That's fundamental to everything you do to build a car and that whole cycle. So how does that apply to safety? Well, again, let's put this at I'm going to insult your intelligence for a minute, because I know I'm working with some real smart people that are on the line, and you're real familiar with how to build a car. But I like to pull this out for a minute to make you think a minute. So I start with, I put a specification out. The marketing team comes up with a new car that they want to build. They develop a set of specs around that. They toss it over to the engineers, who then start to build a virtual design, if you will, and they run as part of that, they gradually build up the car. They put the specs in there. They simulate what can happen, all the way from how the car performs on the road to crashing. And at some point they decide, hey, that simulation looks good. Let's go build one of these things, and we'll bring it into the lab. I'm going to crash it into the wall, see how it performs. It loops back, and they feed it back into their development cycle. And then at some point they put it out on the road, and they see how it performs on the road. And wouldn't it be nice if this whole process was as pretty as I show it here on this slide, and that data could easily be shared back and forth? But you probably know that there's hundreds of applications involved in this process, that there's thousands of engineers involved in this process. And so the ability to slide this window back and forth is really difficult. And if there's any there that has this problem solved, I want to talk to you, because I've yet to see anyone who's been able to really stay ahead of this process. And why? Well, engineering data is different fundamentally. The IT guys are typically not focused on this type of data. I see battles all the time between IT and the engineers. In fact, I was on the phone yesterday with a major OEM, and there was a big dispute, but it had nothing to do with us. It had to do with the engineers and the IT folks battling over tools and data and who controls it, should happen. And if you think about it, what is an engineer trying to do? Fundamentally, they need to measure things to a very extreme accuracy. Many floating points, millions of files are created with lots of floating point decimals, and these need to be applied into scientific applications. But more than just that, they need to synchronize it from multiple sources. So if I have video, if I have CAN data, if I have weather related data, all of them are coming from different sources. I want it to be aligned on a very particular time set. And then once that data has been collected, run a crash, and it's a snapshot of time, there is a lot of anomalies and detection that needs to happen. So tools to better disseminate those and capture those events. And this happens in a very complex multi-step analysis, where over a period of time, where multiple engineers need to disseminate that data. If you think about this, it's different from what the IT guys are typically used to deploying in technology. Now I'm going to add to it a whole new vocabulary. And I go back, I remember the first meeting I was in, and I am by no stretch of the imagination trying to say I'm a safety engineer, because I've been in those meetings. I mean, and I can remember the first meeting I was in, for the first 15 minutes. And if you're familiar with the term TLA, 3-letter acronyms, they threw around more TLAs, and then TLAs to define what the TLA was, than I could keep up. I left there with my head actually hurting. This is like, 5 or 6 of them, and there's literally hundreds of thousands of these TLAs that are used in the world of safety. And what's happened over the past 100 years is the first 100 years were very focused in the industry around passive safety. How do I keep somebody safe in the vehicle when I get in a crash? I want to now, obviously, the where you want to go with that is turn into active safety. How do I avoid a crash in the first place? And to do that, all of these new standards have been involved, and standards bodies are in place. Body standards are developed around algorithms, around terms, around the way to measure things, how to categorize those things, and that is a big, big job. And if I apply that to this new world of road, of active safety, and you look at what's coming from 2020 and beyond, it's just going to escalate. And if you think about where we are today versus, this connected vehicle, and I've got an automobile that's dealing with electric bikes, and people and safety movers, it's going to be an incredible set of standards and measurements that are going to have to be developed. So that's the active safety piece. The thing that struck me today, I was doing, like I said, I did a little research. I went out to the IHS website this morning, and I happened to see that they had an interesting blurb on there around the driver assistance systems, and how they are really helping eliminate crashes, right? And that is improving them. But they did a study recently with BMW, and they're saying, hey, the overall impact of this is still a bit murky. So you should read that to mean that there is still a lot of work to do in this area, and you probably, the engineers on this phone probably know this better than me. So I say to the engineers I work with is, are you data ready? I have a set of standards to adhere to. I've got scenarios that need to be adhered to, and keeping up with those standards is a full-time job. As I work with the different regions around the world, my feeling is that Europe, this is just my opinion, take it for what it's worth, seems to be ahead of the game in this area, in that they created the Euro NCAP standard body, which then coalesced on the ISO MME data format, and also standardized on a number of analysis and reporting and tools to support all of those things. And as I mentioned, that the company that had built software in 1965, the engineers there say, hey, I'll just build a new one. And my question to you is that really how you want to spend your time? And it is just to keep up with the data, algorithms that need to develop. If you utilize third parties for that, you're probably going to be much further ahead of the game. I call that the value chain of data. So, how do you want to spend your time? Most of the engineers I know would like to be up here in this right-hand corner. How do I apply new insights from those analytics? Are there things with artificial intelligence and machine learning that can be applied here? How do I create digital twins of that? And that's really where the companies I work with want to be. Unfortunately, many of them are mired in this data management layer. They're usually pretty good at acquisition, but along the way, there's a lot of steps between acquiring that data and then being able to put it to good use. And that requires a lot of knowledge and tools and insights. And so this is why it calls it my birthday cake slide. It's got lots of, it's a very colorful one, but I use it really for you to, as a way to classify and think about this problem from a software perspective. And that's what this is meant to represent. So starting at the bottom from data safety all the way up to ADAS, what I try to do here is let me walk through a few of these things and start by some of the partners we're working with around virtual crash testing and simulation. One of the leaders in the industry is ANSYS, Elestina. There's many more like Altier and others that are in this market. Part of the reason for this is the focus here on their Elestina product that allows you to do a great job of simulating crashes, looking at the progression at a real good system level, and they can look at what the deformation impact is of the impact of a car, and they can apply their finite elements in multiphysics towards these structures. So a huge set of work in mathematics, and Elestina has done a great job of that, and we've been working with them on how we can help them supply them with data around this whole area. Leaders in the industry, one of our favorite partners, and actually we've been working with them since the start of this company. A company in Germany called Mezex. They have a set of products. Their family of products is called X-Crash. It is really a leader in the industry when it comes to passive safety. They grew up in working with the Euro NCAP organization. The NCAP Europe has standardized on their set of tools, and they are the shepherds of all of the data that comes out of NCAP. They work with them on a regular basis, update their data so that engineers can take a look at how they're performing against those standards. And they also stay on top of what are the new standards that are coming, what algorithms are coming that haven't been released, so that they can really give you a head start. So this is a a really important piece of technology. Viviota, I'm happy to say, is a strong partner with them. We've integrated it with our TTI platform, and we're exclusively reselling this product across North and South America. So they support many regulations. This is just a small sections of them. But the other piece that they've added is active safety, where they've did a wide range of tests around, obviously around AEB and forward collision piece and lane support systems. They've developed analysis tracking for the international standards. And they're continuing to expand this and throw updates. I'm kind of giving it a short shift here because they have a whole family of products. They have products that support dummy ATD pieces and AHIC and all kinds of different standards. And it's a pretty sophisticated piece of software that is, in terms of saving time, this is their leader in this marketplace. The other company that we've done a lot of work with is IPG Carmaker. We just completed a project with them for a major OEM in Japan, actually. It is around ADAS and driving dynamics and incorporating simulation into this whole process. They've done they have a very cool product that incorporates intelligent driver models. It has real flexible road and traffic models already built. All the simulations are there. It has open interfaces to other third-party tools. Lets you do things like vehicle in a loop, and it enables a lot of interactive and maneuvering. So a very popular package out there, and we've done quite a bit of work with them. And then, at the bottom of this stack, I'll talk about Time to Insight and our platform. So as I mentioned to you, we've been around now for almost 5 years. We've really expanded our platform. We've incorporated in the lower left-hand corner our work with the XCrash client and connected to our core products, which is our Prep, Look, and Crunch that run on a server environment. We also incorporate analytics for the test cell engineer as well as the R&D engineer, and incorporate analytics within that. And then, of course, the TTI safety is focused on the active safety and the ADAS engineer, working with companies like ANSYS and IPG, but also developing some of our own technology. And then at the top of the stack, which has always been part of the vision, we're just now starting to, we started a project around AI and ML with a customer, and we're developing technologies to really enable those parts. I think central to all of this is a thing that we kind of call sensor fusion, which has been bandied around the industry quite a bit. So we're just utilizing it, maybe repurposing it, and maybe abusing that term. But for the engineers that we're working with, it's really the combination of taking a whole bunch of data that might have been collected in a trunk of a car or other places. It is taking sensor data that could be synchronous LiDAR data, radar data, all that needs to be incorporated. And at the same time, they're developing, there is location environmentals that need to be captured. And one of the most important thing is this thing we call event management and detection, where engineers can set up a parameter and a set of events that they can track so that they can do data forensics and other things. All this comes from this data comes from many sources, and being able to create a standard methodology to capture all of this data, access it, and locate it is an important part of it. So we built the Time to Insight solution. This is the one that shows, we did this with IPG Automaker, where for this particular customer, it has a data ingestion engine, a data search engine. We incorporate that into a monitoring slot piece, and you can see this is a pretty busy panel, but in the upper left-hand corner, you can see that there was a bunch of videos that had happened, front and rear cameras. They went out on the road with it and outfitted a car with all of that. They tracked in the lower left-hand corner. You can see a lot of channels that were tracked, and in this case also included GPS data. They were able to track in real time where the car was, align where the car was with the video, and then on the bottom, they plotted the CAN data that went along with that. So a pretty rich set of interfaces. What was useful here is it allowed you to align a lot of the events that were happening on a very precise piece, do the reviews you need, and be able to roll with that. if I move this thing forward a little bit, I think let's talk a little bit about AI, and you can spend hours talking about this. To be quite frank, when we started the company, we were thinking we might be an AI company, but it became real clear as we worked with customers, they weren't ready for it. And more than that, if you see, there's not a lot of, I wouldn't say that there's a bunch of standard products out there. There are some. I think they're lacking, but it's also clear that the data to do effective AI and machine learning at an automotive OEM resided with the OEM. So a better spot for us would be to give you some standard tools, help develop some of those pieces, and then let you go off and innovate and let engineers do what they do next. Nevertheless, we are, with our first project, we've got a few AI modules that we're using to kind of get the ball rolling. We've got some work going around intelligent health monitoring, so I can tell whether a sensor is working or not and whether the data is coming. I can learn from that. I can do fault inspection. I can classify these automatically. And then one of the biggies is visual object recognition. So within a video, for example, we could tag it an object and then be able to learn from that over time. And I would say that these are things that are at the very beginning of this. And so I don't know how many people out there have worked with AI and machine learning. Just to give you a little overview, if you look at this complicated chart, at the top, we talk about building AI models and frameworks where you take data that's been driven, and then what you do is you build these things called inference engines, which clearly basically is a set of rules and allows you to pull, extract knowledge from that information, apply it to your model, and learn. Hence the loop and machine learning and AI, and that's that loop here that makes the world go around. At some point, that engine looks pretty good, or that new AI module looks well, and you want to deploy that to the object that you want to apply that to, and that's where this whole framework comes into place. So the way we look at this from an automotive perspective is build a set of pre-trained modules, optimize those modules. At some point, you want to execute the AI and machine learning piece, generate some results, feed that back into this process so it's a closed loop process. So if you go back to my original chart about collecting data along the way, standardizing that data, this is your framework to get to that whole beautiful world of AI and ML. And to do that, we have introduced a new product. It's a video development environment for AI. It'll have a set of things on here, everything from LabVIEW to C++ and other aggregators. It'll be deployed on top of CPUs and FPGAs, and we've worked with HPE on deploying those analytic engines and taking care of various accelerators. So as I mentioned, you know, this can take on a whole world of its own. But you can kind of see then, you know, if you think about this whole piece holistically, layering these different solutions on top and utilizing and connecting to the simulation engines on both ends of this, it gives you a whole set of solutions to work with. And of course, it's kind of ignoring what you're doing today. Obviously, companies like DTS and Geomanetics are already out there. Many of them are also deploying tools. We've had with discussions with them as well as to how we might be able to be a help going forward. So I've thrown a whole bunch of information at you. I'll kind of bring it all full circle. You know, one of the biggest struggles I see when I'm working with an engineer, they see the software we're building, they say, oh, this is awesome. I love the software that you're doing. But man, I got to figure out, I need somebody to run the project. I need money. I need somebody to support that I do this. I need, you know, I may need new compute hardware. You know, so I need IT support. So if you step back and you look at this, you go, this problem can be overwhelming. And this happens all the time to us. And what I do with these engineers is I break it down into a pretty simple process. Everything is 3 phases. The first one is focused on, we develop, we do a little workshop. We come in and understand the problem. We identify an acute pain point that demonstrates a whole bunch of value very quickly. And I like to do these in an agile methodology. So we typically can do these in 2 to 3 months. mainly it's usually calendar time and not development piece. We can deploy our software to go do that, teach the engineers how to do it, and then we collaborate on that. So once you've solved the problem, you demonstrate the value, you go on to the next one and the next one. And that's really the journey that you're on. Our largest customers, we've been working with them for usually 2, 3, 4 years. And we continue to grow and solve more problems for them. And the key to all of that was laying that data backbone, and then, you know, obviously growing and working through that as they move on to the next thing. So appreciate that. I'm gonna stop right now. I see my my light there is kind of flashing. Let's see if we've got any questions. If you want, you can submit these through a chat window, and then I'll be able to see them. So let me. So, hey, Wyatt, would you read that first question that you saw?
Yeah, one question that I got, it was relating back to the birthday cake, if you will, and the ability to run simulation and do active safety testing. And can you do that without a data backbone? Is that possible at all? Or?
Oh yeah, good question. And absolutely, that's the way it's done today. It is typically done on an engineer's desktop, or, you know, multiple engineers' desktops, and it is done today. We're really suggesting that if you step back and you tie these pieces together, that you'll have a much more you know, a better framework to work on this in the future. So no, thanks for that question. Good question. What else? Yeah, Wyatt, read the next one. I don't have access to them right now, so.
So one of the other questions that we got was, is MESX, the company you mentioned before, is that available in the United States at all currently?
Oh, absolutely. We are, as I mentioned, they're a strategic partner of ours. We've done a lot of work with them in terms of joint development, joint selling. We're an exclusive their technology here in North and South America, and we have numerous customers using it here. So, good question.
And one came in right before that one. It was about the sensor fusion piece. They were wondering, can sensor fusion be used in safety as well as other parts of research and development, or is it only geared towards one specific area?
No, actually, that's another great question. We're seeing the early applications of sensor fusion in ADAS. In fact, it's actually this is again where our technology is pretty much ahead of the problem. But, you know, literally what people are asking us for is that time alignment feature where we can take multiple cameras and just align the data. I mean, just so that they can describe what's in the data. So that's the very basis of that. And then long term, they want to be able to exploit the power of that. But right now, it's very clear in that environment, and that's often one of the major use cases for it.
We have time for one more question. I'll read this last one. If we weren't able to answer all the questions, sorry. Feel free to reach out. You see our emails there. But this last question was, so when you begin to work with someone, what does a typical project look like, time cycle? I know you kind of talked about at the end, but can you go into a little more detail?
Yeah, as I mentioned, we tend to, so it varies depending on the complexity and the size of the scope of the project, right? It varies from 3 months to 9 months. But, you know, there's some early work where we sit down and understand what their current install base looks like, what data they're dealing with. There's some informations that have to happen. So that can actually, the upfront work and preparation for this can take several months. And then you obviously go through a cycle where you deploy technology, train everybody on that, and you begin to use it. So it is not uncommon for us to be into, a 6 to 9 month cycle to kind of get this thing started and rolling. If you want to know more about the individual tools or about the process, we'd love to engage with you on a project. My email and Wyatt's email are both up there, and you clearly can get a lot of information from our website and check out the others as well, MESX and IPG and Ansys. I'm sure you're familiar with a lot of those vendors there. And so Pradeep, I'll get back to you. Let's get back to you on that, and so I can understand a little bit better what your questions are. So I think with that, I don't see any more questions. Do you, Wyatt? So we really appreciate your time. I hope that you learned something today, a word or two maybe that you didn't know, and I hope everybody stays safe and is able to get some work done in this tough environment here. And as we move forward, if there's anything we can do to help you, we're here. Please reach out, and love to talk to you. So thank you. With that, I'm done for today, and thank you, everybody.